All right, good evening, mathematicians. Here is the video I promised that walks you through the samples and populations test review that you received for homework today. Okay, so in this video, I'm just going to walk through the entire study guide, reviewing the concepts that we have learned so far. Well, with that, let's go ahead and dive right in. So, following the directions, it says use the following table for questions 1 and 2. Okay, so it looks like, here we go, I have a bunch of numbers here. I guess we're making something with raisins. Okay, but the first question wants us to find the mean, the median, the mad, and the range of the number of raisins. So I think just to start us off, I think I'm just going to write my numbers in order from least to greatest. So I think 13 is my lowest number. This is just to prepare myself for finding the median, and honestly, it's, I don't know, for the median, and also just when we calculate the mad and everything like that, it's just nice to have an organized set of numbers. So I have a 13, then I have a 14, I have an 18, 19, 19, 19, and 3, and then I have two 21s, and then a 22. Okay, there we go. All right, in terms of showing your work, for the mean, I'm not going to have you guys write 13 plus 14 plus 18 plus 19 plus 19, and so on and so forth. Instead, what you can do is you can just do the sum of your numbers and then divide it by however many numbers we have. So in this case, I'm going to type into my calculator 13 plus 14 plus 18 plus 19 plus 19 plus 19 plus 21 plus another 21 plus 22. So that is 166. And I divide this by 9 because I have 9 numbers in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Let me double check this. 13 plus 14 plus 18 plus 19 plus 19 plus 19 plus 21 plus 21 plus 22. Okay, good. And so this right here, 166 divided by 9 is what you're going to write down. And I would get into the habit of rounding to the nearest hundredth, just because I feel like that's pretty standard in high school. So it's approximately 18.44. Next, the median. The median is a nice simple calculation. All we got to do is find the center value of our data after, of course, we've listed them in order, which is another reason why I said to list them in order. It looks like our median is 19. There we go. Okay, now I'm going to find the mad. So remember, the mad is a 3-step process. So first step in that process was to find the mean, which we did. Now we're going to subtract each data point from the mean to see those distances, or see those differences. So I'm just going to do 18.44 minus 13, and I'm going to write these down just so I have them ready to add for my final step. So 5.44, then I do 18.44 minus 14, and that's 4.44. So that's from there, that's from there. Then from the 18.44 minus 18 is 0.44. 19 minus 18.44 is 0.56. So 0.56, 0.56, and 0.56. I love when we have repeats when we calculate the mad, because then you only have to do it once, and then you have to... Anyway, it makes things a lot easier. 21 minus 18.44 is 2.56, 2.56, another 2.56, and then 22 minus 18.44 is 3.56. There we go. Okay, so the final step of our MAD is to add all of these things together. Or, yeah, add all of these things together and then divide by 9, or we can find the mean of these differences. So, let's, again, you don't need to write 5.44 plus 4.44 and so on and so forth. You're just going to write the sum of your numbers divided by 9. So 5.44 plus 4.44 plus, whoops, I think I added one too many. 5.44 plus 4.44 plus 0.44 plus 0.56 plus 0.56 plus 0.56 plus 2.56 plus another 2.56 plus a final 3.56. There we go. So we have a total of 20.68. 20.68, and we are dividing that by 9. So our MAD is approximately 2.29. Hold on. So 2.297 is my decimal. So I'm going to round that to 2.30. That's my final answer. So that is my MAD. Okay, and then the last thing is my range. So adding to my list here. All right, the range of the number of raisins. Take the lowest, subtract the highest. So just show me what numbers you are subtracting. So the maximum is 22. Subtract the minimum value. 22 minus 13 gives us 9. So our range is 9. Ooh, getting a little cramped here. Okay. Alrighty. So let's go ahead and create a line plot of this data. Hopefully we have enough tick marks here. Let's go ahead and see. So my lowest number is 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, whoops, 22, and 23. Excellent. With your line plot, you guys, do not forget a title. So this is going to be the number of raisins. Okay, and a line plot is different than a dot plot. A line plot uses x's for data values. So just be aware of that, okay? So we'll put an x above 13, an x above 14, there we go, an x above 18. So we have a nice gap here. We have 3 at 19, 1, 2, and 3. We have nothing at 20, and we have 2 at 21, and then we have 1 at 22. So kind of sporadic set of data here. It's kind of spread out. Okay. So now we have question 2a. So what percentage of the data falls within 1 MAD, 2 MADs, and are there any unexpected values? So this is the lesson that we did today in class. So what I would do is I would go ahead and mark where the mean is on your number line. So our mean is 18.44, so I'm going to say that's directly in between 18 and 19 right there. And we're going to create our M1 fences, and then we're going to create our M2 fences, and then we're going to see how much of our data falls within 1 MAD, within 2 MADs, etc. So let's see. So 18.44 is my mean, and I'm going to go 2.3 above that. So I'm going to add 2.3. So now I'm at 20.74, which is going to be about right here. So there's M1. Okay, and then I need to go 2.3 below the mean. So 18.44 minus 2.3. So that's 16.14, which is right here. So there's M1. So the number of points that is within 1 MAD, well, let's count. We have 1, 2, 3, 4. 4 out of 9, right? So 4, my total is 9. So let's go ahead and change this into percentage. 4 divided by 9 gives me approximately 44%. So we'll say within 1 MAD, or 44% of our, we'll write sentences. 44% of our data falls within 1 mad. Okay, let's move on to 2 mads. I'm going to use green. Okay, so I need to go an extra 2.3 above the mean here. So when I added 2.3 up to 18.44, I was at 20.74 for M1, so I'm going to add another 2.3. So now I'm at 23.04, which is approximately here. So here is M2. So here's my first M2 fence. 18.44 minus 2.3. So we were at 16.14. We're going to subtract another 2.3. And now we're at 13.84, which is approximately right here. And so here's our final M2 fence. Okay, so what percentage of the data falls within 2 mads? Well, we're going to count every x that we see. 1, 2, 3, 4, 5, 6, 7, 8 within my M2 fences. So 8 out of 9. 8 divided by 9 gives me approximately 89%. So answering the question down here, 89% of the data falls within 2 mads. Okay, now are there any unexpected values? Are there any outliers here? So do you see any data values that are outside of our M2 fences? Yes, in fact, we have 1. So if we change this into a percentage, 1 divided by 9 gives us approximately 11%. So 11% of the data are unexpected. Right, so anything that falls outside of that range of 2 mads we say is an unexpected value or an outlier. Okay, so there we go. Awesome, let's move on to question number 3. So following the directions, it says, give an example of each type of sampling plan. Be specific. Okay, so please please be as specific as possible. Just to be safe, okay? I don't want to have to take off points because your plan is too vague, or some of your plans may overlap in some way, okay? So try to be as specific as you can. Okay, so an example of convenience sampling. Well, remember, convenience sampling is just convenient, right? It's kind of like the lazy person's sampling plan, okay? So the example that I think of is I distribute a survey. To the people on my bus. Right, these are people that I was going to see anyway, right? They just happened to be in the wrong place at the wrong time, and I was like, hey, take this survey, right? So that's kind of the essence of convenient sampling. It is convenient for you because all of those people are already there. Okay, let's take a look at systematic sampling. This one was probably one of the more difficult ones to define. The formal definition of systematic sampling is that, yes, it follows a pattern. The sampling plan follows a pattern, but the very first person that you choose is at random. I know it's kind of strange, but examples that I would take are things like every fifth person that walks, that walks into TPMS through the front office will take my survey. Okay, so the essence of systematic is this system that's in place. Every fifth person, this kind of pattern that the sample follows. It's getting closer to our random sampling a little bit. You know, you may not know everyone who walks into the office, but that's kind of the point. That's what gives us our representative sample. All right, let's take a look at random sampling. Key component of random sampling, probably the most important aspect, is that everyone has an equal chance of being selected to take the survey. Okay, so so let's say that I assign everyone at TPMS a number. I then use a random number generator. Oops. To select a sample of 100. Something like that. So, you know, this random number generator, the probability of choosing every single person at TPMS is equal, right? The probability of being selected is equal across every single person at TPMS. That is the important part of random sampling. Okay, and the last type of sampling plan that we've talked about is voluntary response. So one example that I'm thinking of is, I asked the folks that work on TPMS TV. So I asked the ASB kids who are making the announcements to make an announcement that I have a survey. I have a survey to give out. If you're interested in taking the survey, please stop by the library during lunch. That's what I'm going to say. So I have a survey. If you can, stop by the library during lunch. If you can, stop by the library during lunch to take it. Okay, so voluntary response sampling relies completely on the good nature of of others. Hopefully you get some volunteers to take the survey. There are instances where, you know, you don't get very many volunteers, and that's really the issue with voluntary response sampling. It's a little hit or miss. You may get data, you may not get data, and yeah. So random sampling just kind of tends to be our best bet. All right. I will say that on the test, if you guys give me examples like these, I will not count those, so please try to be creative and come up with your own, okay? All right, let's keep going. Questions 4 and 5, we're going to write the 5-number summary and create a box and whisker plot for the given data. Okay, so we need to do 2 things, 5-number summary and create a box and whisker plot. So make sure you're doing both of those things, please. Don't forget one or the other. Okay, so 5-number summary, that's involving medians, right? So I need to set up my data in order from least to greatest. 37, 38, 39, 44, 44, 47, 40. Hey, look, it's already in order. Cool, I don't need to do much. So I like to write the 5 numbers summary, or the components of the 5 numbers summary, just to remind myself. It's also just good practice, so that way you don't mess up, and there's less room for mistakes. Okay, so these are the things that I need for my 5 number summary. Okay, so let's go ahead and find the median first. Actually the minimum is 37 and the maximum is 48. I think the max score is like 50 or something. So if you're wondering if this test score, or this test is out of 100, then these people might be scoring pretty low. Okay, so there we have our max and our minimum. Let's go ahead and find our median. Crossing out, crossing out, crossing out. Looks like we have a tie between 44, 47. So I'm going to add those two numbers together. 91, and then I'm going to divide this by 2. So that gives me 45.5 as my median. Okay, so I'm going to add 45.5 into my data here just so I know where it is and where it splits my data into 2. So 45.5 is there. Okay, so my lower half is blue, and then my upper half is going to be this red section here. Okay, so for quartile 1, I'm going to find the median of my lower half. So boop, 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 boop. There we go. 39 is quartile 1. And then I find the median of my upper half, and that gives me quartile 3 at 47. And there is my 5 number summary. Now let's create our box and whisker. So some of you have forgotten that a box and whisker plot needs a number line. I will not give you points if you just draw your box and whisker. Okay, it needs a number line below. So let's see, my minimum is 37. My maximum is at 48. I think I need 11 spaces in between, something like that. So try your best. Doesn't need to be perfect. 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. Okay. Again, doesn't need to be perfect. Okay, and I'm going to label everything. 4, 45, 46, and 47. Okay. Let's go ahead and graph this. So my minimum is at 37. My quartile 1 is at 39. 45.5 is my median. 45.5 is like all the way over here. 47. Actually, guys, I'm gonna make this a little bit more spaced out. I know, I just told you that it doesn't need to be perfect, but it's gonna bug me. Okay, 45, 46, 47, and 48 is going to be at the very end. So there's 48, 46, and 47. Okay, that's a little better. Alrighty, so 45.5, this no longer applies. 45.5 is halfway between 45 and 46. Then I have a point at 47, and then at 48. So then my box and whisker, I'm going to connect the middle 3 lines, just like this. And then I have my beautiful whiskers. And there's my box and whisker plot. Okay, so there we go. Number 4 is done. Let's do the same thing for number 5. Here we have different states and the life expectancy, so the age that people normally pass away at. So we're going to organize this data in order. Is it already in order? Hey, look at that. Cool. We don't need to do much. Again, always double check to see if your data is in order. I believe on the test it will not be in order, so you must do that before. Okay, so I'm going to prepare, actually I'm not going to write where I'm going to draw my box plot. So, start with my minimum, go to quartile 1, then my median, then I go to quartile 3, and then my maximum. Just so you guys know, I think on the test, the median may be marked as quartile 2. Okay, just a heads up. They mean the same thing. Quartile 2 is the median, and the median is quartile 2. All right, so it looks like my minimum is 74.2. My maximum is 79.7. Okay, let's go ahead and find the median here, crossing out from either side, crossing out, crossing out. There we go. If we have 2 in the middle, right, halfway in between 78.2 and 78.4 is 78.3. Okay, so I'm going to add 78.3 right here, 78.3. That way I can visualize, so the blue is my lower half, and I'm going to do green for my upper half. There we go. And then I'm going to find the medians of both sides. Halfway in between 77.7 and 78.1 is 77.9. So I'm going to write that for quartile 1, 77.9, and then halfway in between 78.6 and 79.1 is 78.85. Let me double check that. 78.6 plus 79.1 divide by 2. Yep, 78.85. I'm going to leave it as 78.85, just because, you know, it's already in rounded to the hundredths, or not rounded, but it's left with hundredths. Okay, so let's go ahead and graph. We need a number line, please don't forget. So since I'm dealing with decimals, I'm not gonna make each tick mark a decimal. Instead, I'm just gonna use whole numbers and then approximate using my box and whisker plot. Then I can add in the actual values above my box and whisker plot. Okay, so let's see. It looks like I need to go from 74 to about 80. Okay, so here's 74, 75, 76, 77, 78, 79. I'm gonna extend this a little bit. And 80. There we go. Okay, and let's go ahead and graph. So my minimum is at 74.2, so that's going to be in between 74 and 75, a little closer to 74. 77.9 is my quartile 1. That's going to be in between 77 and 78, a little closer to 78. 78.3 is my median, a little closer to 78 there. 78.85 is quartile 3, so that's going to be a little closer to 79. And then 79.7 is my maximum. And make your box, connect your whiskers, and there we go. So again, we're going to label these so that way they're exact and you know exactly what these what each of these numbers are. So then we have for the median 78.3, then we have 78.85, and then of course we have 79.7. All right, there you go. So those are the core topics that we covered in samples and populations. Now I'm going to take a look at the extra credit problems. And again, these are the types of extra credit problems that you may or may not see on the test. Okay, So it's actually giving you guys a little bit of a preview into our next unit. So we're reviewing how to find the area of certain shapes. We're also reviewing, or we're also going to be learning about surface area, and then of course equations. Equations never go away; they're constantly there. So we're going to take a look at how to solve them. Okay, so finding the area. The area of a triangle. So area of a triangle is always going to be 1/2 of your base times the height of your triangle. So the base of my triangle is this red section right here. So I know that I'm going to be multiplying by 4, right? 1/2 times 4, and then the height of my triangle, they actually give me in this purple right here, which is 1.5. Now I just got to get out my calculator. 1/2 times 4 is 2. 2 times 1.5 is 3. So the area is 3. Then you also need to include your units. And because we're talking about area, our units are inches squared. So there we go. Okay, next, a square prism measuring 8 kilometers along each edge of the base and 8 kilometers tall. So giving you guys a visual here. Remember that surface area is, we're talking about 3D figures. Right, so I'm going to try my best to draw a cube here, because that's what we're working with, a square prism. There we go. Okay, so measuring 8 kilometers along each edge of the base. So I'm going to write those in red. So the edges of my base, so this side is 8 kilometers, and then this side right here is also 8 kilometers. And then my height of my prism is also 8 kilometers. Okay? So remember, surface area is the area of each side of my prism. I'm just going to add them all together. Fortunately, this is a cube, which means that one face of my cube matches all of the other ones. So I have an 8 by 8 kilometers square on each side. Okay, so I know that the area of this square is 64. Okay, but then how many faces do I have on a cube? Well, if you think about some dice, right, each dice has 6 sides. So I'm going to have 6 of these faces, although they're not drawn to scale. In other words, you can think about this. Well, if I know 1 is 64, how many faces do I have in total? I just multiply this by 6, and 64 times 6 gives me, here I'm going to rewrite this. 64 times 6 gives me 384, and we are in kilometers, and we're talking about area still, so it's kilometers squared. There we go. Okay, let's move on to some one-step equations. Okay, that just means it takes one step to solve for the variable. So I like to draw lines down my equal sign, because I'm sure your math teachers have said what you do to one side of the equal sign, you must do to the other side. So I always draw a line where my equal sign is. That way I can see what I'm doing to one side, and then I'm like, oh, okay, I did it to this side. Now I have to do it to the other side of my line. Okay, so it's just a visual marker to help you out. Okay, I read this equation as m divided by 2 equals 16. And the reason why I read this is because in order to isolate the variable, we have to undo the things that are happening to it, right? So what's happening to my variable? Well, I am dividing it by 2. So in order to undo all of that, in order to undo dividing by 2, I need to do the opposite of that. So I'm going to be multiplying by 2. Okay, I'm multiplying by 2 over 1. Let's see what happens when I do this. I actually can cross cancel here. So my 2's cross cancel and they become 1's, and then I'm just left with 1m over 1, which just is m, right? Really, I don't need this middle part here. I don't need this because you should be able to deduce that, 1 times anything is just itself. Okay? All right. Okay, so now here's a part where I'm like, okay, I did stuff to the left side of my equation, and now I need to do stuff to the right side. So I'm going to do the exact same thing, so I'm just going to multiply this by 2. 16 times 2 gives me 32. So m in this case is equal to 32. And there we go. All right, one more. So again, I draw my line down the equal sign, okay? So I read this as negative 2 times m equals 144. Okay, so here we have a single step equation with integers. We have to be very careful about the signs, whether numbers are positive or negative, because that will severely affect our answers here. Okay, so in order to undo this negative 2 being multiplied, or our variable being multiplied by negative 2, we need to do the opposite of that, right? So what is the opposite of multiplying by negative 2? Hopefully you said dividing by negative 2, and I always show my division as fractions because that's a little easier, okay? So I'm going to divide both sides of my equation by negative 2. These negative 2's are going to cancel each other out. What I mean by canceling each other out is that, well, if I think about it, what's negative 2 divided by negative 2? That just becomes a giant 1, which you may have heard before, right? So 1 times m is just m, right? So when I say cancel out, this is what I mean. The 2's become a giant 1, so I'm just left with 1m, okay? And let's go ahead and divide 144 by negative 2. 144 divided by negative 2. I'm going to write the number, and then I'm going to ask you, is it positive or negative? Hopefully you said negative. When we multiply or divide a positive and a negative number, your answer, your product, or your quotient will be negative. Okay, so m is equal to negative 72. Now, the way you would check your work is you would just plug this back in to the original equation. So, negative 2, we have negative 2m equal to 144. We're claiming that m is equal to negative 72, so I'm just going to substitute negative 72 into my equation, and let's see if it's true. Does negative 2 times negative 72 equal positive 144? Indeed it does. If this equation is true, then that means your answer is correct. Okay, we're gonna practice this. We're gonna drill this so much over the course of this year, especially when we hit 8th grade math, because we're gonna start talking about two-step and multi-step equations. Okay, so hopefully this video helped. Remember, our test is on Wednesday, so keep studying, keep practicing. Please come see me for questions. All right, that is it for me, and I will see you in the next video.